Hello everyone. In this video we're going to be thinking about the basics of burning fuels. Now when a chemical burns, oxygen, so we're thinking about just burning in the air, oxygen joins with the atoms in that chemical to form an oxide. And this reaction also gives out energy, usually in the form of heat and light. And we can show that the oxides formed are hydrogen oxide or water and carbon dioxide by carrying out a very simple experiment. So let's put in a word equation first of all to represent what we're after. We're saying that a fuel plus oxygen when reacted will give carbon dioxide plus water plus, we'll put it in brackets, energy. So we get a defined quantity of energy from that reaction. So we're saying that the basics of burning fuel is that when you react a fuel with oxygen, we get carbon dioxide and water being produced. So let's think about this experiment that we've got up at the top. So we've got a clamp stand with a clamp, so I'll just label a few bits just so we're clear. So we've got the clamp stand here. Attached to a funnel, inverted funnel with a candle, and that's leading down via tubing to a conical flask. We've got the thermometer in that flask. You can see there's a bung just there sealing off that flask. Then this tubing continues into this what's called a U tube, or we're going to call it a U tubing here, that's sealed both ends, but it's in cold water, and then the tube is continuous with one that extends down into a test tube full of lime water. And we've got a suction pump on the right hand side. So let's think about how things are going to appear before this experiment. We're going to fill in this table along the way. So before the experiment, the appearance of the candle, well, the candle's going to be, let's just put intact, as in it's not going to appear that we've burnt any of that wax. The temperature inside the conical flask most likely is going to be air temperature. So let's say that's room temperature. Let's just pick a value. Let's say that's 22 degrees C. The appearance inside that U tube is going to be clear inside there. And the appearance of lime water, well, lime water goes cloudy when there's carbon dioxide, so this is not going to be cloudy, it's going to be clear also. So let's think about this experiment. We have our candle, we'll colour it in purple here, so here's our candle, and let's imagine that after a certain time period we light the candle. So here's our flame. So let's think what's going to happen after the experiment. What we should notice is that the candle will have melted a little bit. So we'll put the appearance of candle, we'll write in melted. I'm going to do the last column, the reason why, once we put all these four in place. The temperature in the conical flask might be, let's say 28, will have risen. The U tube, if we will look inside, we should notice that it appears almost wet. So it should appear moist inside, if you like, or wet. There should be some vapours within that U tube, and the lime water will have gone cloudy. So let's think about why these are the case. Well, candle, it started intact, it's melted. The reason why the appearance in the candle chain is because we have burnt the wax. The wax has been our fuel. So we have used up our fuel essentially. And that's why the wax candle appears to have melted. Now, temperature inside the conical flask, well, as hot air rises, that hot air around the flame will have gone up through the funnel, down along the tubing, so it would have gone up and along down here, and would have passed into this conical flask. And it would have been carried up along the rest of the tubing, but whilst in the conical flask, it would have increased the temperature within it. It would have provided more kinetic energy to the particles inside that conical flask. So it would have transferred, if you like, the heat energy to the particles within the flask. So the temperature would rise, so the thermometer would show a greater value. So the temperature inside the conical flask appears to rise because we are producing heat energy. So heat energy is the reason why the temperature rises in that conical flask. So if we just go back to our original equation, fuel and oxygen give CO2, carbon dioxide, water and energy. We've explained the energy component because that energy has been used to heat the air in the conical flask. Let's think about the appearance inside the U-tube. It was clear, but because that U-tube is in cold water, it means that the whole of that U-tube, the outside, is very cold. So vapours passing along this tubing, if you like, this glass tubing, that enter here, so any vapours that would have entered here would have been cooled, and you'd get condensation. So that shows that we're producing water. So that accounts for the water, because we're getting condensation of the water in that U-tube. So that's why it looks moist, is perhaps not the best word, wet. Inside the U-tube, you should see water vapours present, because if water was produced in this burning fuel reaction, then you would see water forming almost. I could even colour this whole thing in, because water would form in the base of this U-tube. The vapours would condense within it, but then you'd get a collection of water at the base here. And that would imply that water was produced and was condensing in this apparatus. So let's finally explain the lime water. The lime water goes cloudy, and lime water turning cloudy is the test for CO2, carbon dioxide. So we have produced CO2, which is carbon dioxide. So that accounts for the carbon dioxide product that we've made. So when we burn this candle wax, the candle decreases in size, the thermometer shows a temperature rise, water collects in the U-tube, and the lime water goes cloudy. And that proves that when we are burning this fuel in oxygen in the air, we are producing energy, heat energy in this example, we are producing water, and we are producing carbon dioxide. So it's just a very straightforward little experiment you can do to prove that with these particular reactants, fuel and oxygen, CO2, water and energy are our products. Okay, hope that helps.